Hello and welcome to this video. In this video we are going to be looking at how we're going to factorize quadratic expressions. Okay, so if you're unfamiliar with what quadratics are, we can always write quadratics in the form of ax squared plus bx plus c. Okay, and when we want to solve those, they will be equal to 0. For now, we're not going to worry too much about solving them. We're just going to worry about factorizing the expressions. Okay, so these numbers a, b, and c are just numbers. Okay, so they're just constant values that will determine the properties of this quadratic, how quickly it changes gradient, where it passes through the y-axis, things like that. Okay. When we factorize them, we're trying to simplify these things. So we can usually factorize things that might be linear. So we might have something like 2x plus 4, and we would factorize by looking at something that's in both of these terms, and we would say 2 is in both of those terms, so we bring that out, and then we'd say x plus 2 is what's left over, and that would be factorizing this linear expression. With these expressions, because we only have these values of a, b, and c, they don't always have to have a nice thing that has a 2 in it. Sometimes we might get an expression that looks like x squared plus 3x minus 10, for example. Okay, and they might tell you to factorize this. Now when we factorize quadratics, instead of just having one bracket like we did over here, we now want to have 2 brackets. Okay, because we need to get 3 terms out, so we're going to have 2 brackets. And our general way we're going to do this is we need to look for numbers that multiply to give this last number, that multiply to give us minus 10. So it's very important that you keep the sign here as a minus 10, but they add to give us the middle number, okay, which is plus 3. Now the reason it does this is because of what happens when we expand brackets. So factorizing is essentially the opposite of expanding. If you want to work out how to expand brackets, I would recommend going and watching that video first. Okay, so when we factorize quadratics, we need to find 2 numbers that multiply together to give you minus 10, but add to give you 3. Now these ones sometimes can take a while to get which ones are which. And so what I would say is go with the multiples first and write a list of everything that you could have. So in this case, I could have minus 10 times 1. I could have 10 times minus 1. I could have 5 times minus 2. I could have minus 2 times 5. And these would really be my options here. And what I have to do now is look in these options and say, if I add these 2 things together, are they going to give me 3? So minus 10 plus 1 is going to give me minus 9. 10 plus minus 1 is going to give me positive 9. 5 minus 2 is going to give me 3. And so that's going to be my 2 numbers. And so what we're going to do, we're going to split an x into the starting point of both of these in order so that when we expand the brackets, we multiply these 2 together, and that becomes x squared. And then we're going to have plus 5 in one of them and minus 2 in the other. And that is your factorized quadratic. Now we could do another example of this. Let's say we had x squared plus 15 x plus 50. Okay, this is just another example that could happen. We'd be looking for 2 numbers that multiply to give 50 but add to give 15. And the numbers that multiply to give 50 are probably going to be 25, 2, 50, and 1. Notice it doesn't matter if I'm doing 1 negative and 1 positive here, because I've got a positive answer. I could possibly, if I'm getting a positive answer, have both of these things be negative. So I could also have a minus 25 and a minus 2. But this, when they're both negative, usually will give you a negative value for b here as well. So I don't actually have to worry too much about those if they're both positive. But I could also have 10 and 5, and now when I add these together, I'm going to get 27, so that doesn't work. This gives me 51, but this does give me 15. So it's going to be x plus 10 and x plus 5. And this is your factorized expression. Now we can use factorizing to be able to solve expressions. So once we've factorized into here, so this is factorizing, we can now, I'll bring this one back here, so we can solve quadratics using this idea of factorizing. So let me rewrite out this this equation, and we said when we're solving it, this has to be equal to 0. And then we said that we can factorize this. So factorizing is basically just making it simpler. So it's x plus 10 multiplied by x plus 5, and that equals to 0. So the way we can solve this now is if we got two numbers that are going to multiply to give you 0, it means that one of these numbers has to be 0. There's no way we can do 2 times 4 and get 0. One of the numbers when we multiply has to be 0. So there are two solutions to this. So this is going to be either x plus 10 is equal to 0, or x plus 5 is equal to 0. So we get two solutions because we can solve this, say that x is equal to minus 10, or we can solve this and say x is equal to minus 5. And now the reason we always get two solutions to a quadratic is because of the way that quadratic graphs look. So this graph is going to pass through minus 10 and back through minus 5. So your graph is going to look something like this. And all solutions that we find are where they cross the x-axis. So this is why we get two solutions, whereas in a linear graph we only pass through the x-axis once, and so we only get one solution. Okay, so this is solving quadratics. We can continue on with this, however, so we can solve even more complicated quadratics. For example, we could take this and we could solve the equation 2x squared minus x minus 10. So let's not solve it, but let's factorize it, and then solving would be the exact same. In order to factorize, what we would usually say is that we need to find two numbers that multiply to give us minus 10, but add to give us minus 1. In this case, it's a little bit different because we have this value for a that isn't 1 here. So because we have a 2 here, we have to actually make sure we're going to multiply whatever's in front by whatever's at the back. So now we have to say we're going to multiply two things to get 2 times minus 10. So we're looking for two things that multiply to give us minus 20, but they will still add to give us minus 1. And in this case, we can go through what they're going to be. We could have minus 10 times 2. We could have minus 4 and 5. We could have minus 2 and 10. We could have minus 5 and 4. And we just have to go through and see which one adds up to be minus 1. So minus 10 plus 2 gives me minus 8, so that can't be right. This is going to give me a plus 1, so that can't be right. This is going to give me plus 8, but this is going to give me a minus 1. But we can't instantly put this into brackets yet. What we're going to do is split this middle term into its constituent terms of having a minus 5 and a plus 4. So I'm going to put the plus 4 first, and we'll see why in a second, and then I'm going to do the minus 5x afterwards. The reason I've done it like this is because I want to split this in half, and I want to factorize each side of this. And factorizing this with a 2 and a 4 is much easier than factorizing with a 2 and a 5. And over here, 5 and the 10, they kind of just work together. So it's kind of just spotting which one is easier to factorize. So if I factorize this side, I can take out a 2x, and I'll be left with an x plus 2. And if I factorize this side, I'll take out a minus 5 and be left with an x plus 2 as well. Now this is the check that you're doing this right so far. You should get the same bracket, and that becomes one of your brackets, and the other bracket consists of everything that you've got left. So 2x minus 5. And this is your factorized expression. We could solve this just by setting this equal to 0 and then saying either x plus 2 is equal to 0 or 2x minus 5 is equal to 0, and we'll get two solutions for that as well. This is your method of factorizing any quadratic, and thank you for watching. Hello, and welcome to this video where we're going to practice factorizing some quadratic expressions. So first of all, we have y squared minus 10y plus 16. and they want us to just factorize this. So we've said we want to find things that multiply to get the number at the end, which is 16, and that add to get the number in the middle, which is minus 10. And we said if we struggle to instantly see a connection, then you can just write down multiples that you can see. So 16, you might say 16 and 1, you might say 8 and 2, and then you want to look for some way that you can make these add to give minus 10. And the way you're going to do that is to say that 8 plus 2 gives you 10. So if you make them both negative, they give you minus 10. And if we do a minus 8 multiplied by minus 2, we get positive 16. And so that means that we can factorize this into y minus 8, y minus 2. And you can always check these. You can check by expanding the brackets. And that should get you back up to this if your answer is correct. Okay, so now second we're going to get a little bit trickier, and this is hopefully going to lead us on to, we're going to go about it the difficult way, and then we're going to come back and then see how we could do it a really easy way. So with the way that we've currently said, we said that all quadratics can be written as ax squared plus bx plus c. In this case, we have an x squared where a is 4, we have a plus c, but we don't have a b. So what we can say is we could write this as 4x squared plus 0x minus 9. And we said in order to factorize these things, we're going to take the 4, multiply it by the 9, and so we're looking for two things that multiply to give minus 36, as in 4 times minus 9, and we're looking for two things that add to give plus 0, or just 0. Now, if we're looking for things that add to give 0, it has to be that number and itself in negative form. And so we can just look at this and we can instantly see that this is 6 times minus 6. Okay, because then if I have 6 times 6 gives me 36, so 6 times minus 6 gives me minus 36, but also 6 plus minus 6 gives me 0. So I can split this 0 up and say that this is 4x squared plus 6x minus 6x minus 9. Okay, and now I draw my invisible line down the center. I can factorize this side. I can take out a 2x, and it will leave me with 2x plus 3. And on this side, I can take out a minus 3, and it will leave me with 2x plus 3. And then that becomes 2x minus 3, 2x plus 3. And this is your factorized form. What you could probably notice is that this actually, in order to get from here to down here, we've employed a thing that we call difference of two squares. Or sometimes you'll refer to it as just dots. The difference of two squares. And essentially what that is we're seeing that this 4x squared minus the 9, this is a squared number, and this is also a square number. So taking them negative, we're just taking the difference of the square numbers. And we can always take a difference of two squares and put it into, if we square root this, we get 2x minus the square root of this, which is 3, and then do the exact same thing with a plus, and that's how we got to this. We could do it with anything. We could do it with x squared minus 49. We could put that into x plus 7, x minus 7. Doesn't matter which way around you place these because you're multiplying them anyway. We could do it with 36 x squared minus 81, and this would become 6x minus 9 multiplied by 6x plus 9, and this makes it a lot easier for us to perform these rather than going through this whole method. We could just basically instantly tell what it's supposed to be. And then finally we're asked to solve this equation. So we're going to have to first do some expanding and then some factorizing at the end. So we're going to have to employ both of them together. So x squared is equal to 4 times x minus 3 all squared. So I first need to expand these brackets, and when I expand them, it becomes that x squared is equal to 4 x minus 3 times x minus 3. And if you remember the FOIL method, we do the first, outer, inner, last. When we employ that method, the 4 gets multiplied by x squared minus 3x plus 9. Then I can simplify this and give me x squared is equal to 4 x squared minus 6x plus 9. When I multiply everything by 4, I get x squared is equal to 4x squared minus 24x plus 36. And now I can move this x squared over to this side, and it will give me that 3x squared minus 24x plus 36 is equal to 0. Now, there's a step that we can do here to make this a little bit easier, and it's the fact that all of these numbers are multiples of 3. So we could actually simplify this down a little bit further, because if we divide everything by 3 on this side, we have to divide this side by 3, but 0 divided by anything is still 0. So if we take a 3 out, we can cancel 3's, and we can say this actually becomes, by dividing by 3, it will become x squared minus 8x and then plus 12 equals 0. So instead of doing that method that we've done before where we have some value that's not 0 in front of the x, we're now instead just taking the regular thing that we would do, and we're going to say in order to factorize this x squared minus 8x plus 12, we're going to look for two numbers that multiply to give 12 and add to give minus 8. Now, things that multiply to give 12, we might have 4 and 3, we might have 12 and 1, we might have 6 and 2. Okay. Now, out of these, 6 and 2 is the one that's going to give us to minus 8, but not in this state. We're going to have to change this to be minus 6 and minus 2. Now that they add together to give minus 8, and when we multiply two numbers that are negative, we get a positive 12, and this is just going to become x minus 6, x minus 2, and that's equal to 0 here, because we're going to solve this now. And what we said to solve these, x minus 6 is equal to 0, or x minus 2 is equal to 0. So that means either x is equal to 6 or x is equal to 2, and those are our two solutions to this equation. And these are our practice questions for quadratics. Thank you for watching.